My name is Samantha George, metric number 183443, presenting my FYP proposal entitled Nanocomposite of Bone Scaffolds Using Bioglass and Cellulose Nanofibers, CNF. My project is supervised by Dr. Dayang Radiah. In order to understand what is bone scaffold, we should begin to understand what is regenerative medicine. Regenerative medicine is commonly used to promote the repair, replacement, or regeneration of tissues which are required due to bone damage and degeneration of bone. Conventional treatment usually focuses on autograft and allograft treatment. Autograft treatment is defined by the treatment of transplanting tissues or bones within the same patient, whereas allograft treatment means the transplant of tissues from another person. Bone scaffolds are defined as materials that are porous and degradable, which can provide mechanical support during the regeneration of damaged or diseased bone. Scaffolds should have certain properties to be functional. The first property is that bone scaffolds should be biocompatible, which means they are able to support normal cellular activity, including molecular signaling systems, without causing toxic effects to the host tissue. Bone scaffolds should also be osteoconductive, which means they allow bone cells to adhere, proliferate, and form extracellular matrix on the scaffold surface and pores. Bone scaffolds should be osteoinductive, which means that they induce new bone formation through biomolecular signaling. Another important property that a bone scaffold should have is that it should be able to match mechanical properties of the host bone and allow mechanical functionality of the bone during the recovery period. Bone scaffolds should ensure that they should be able to degrade with time to allow new bone tissue to grow. And finally, the byproducts of bone scaffold degradation should be non-toxic, whether systematic or locally. Next, I will come to my problem statement of my study. The problem statement of my study is to design a bone scaffold that can promote bone regeneration as well as has reliable degradation time. The promotion of bone regeneration can be measured through hydroxyapatite formation of the bone. If the bone scaffold degrades too quickly, it would lead to a lack of mechanical support which is required by the bone matrix while it recovers. Whereas if the bone scaffold degrades too slowly, it would inhibit the new bone tissue from building an extracellular matrix, which would prevent new bone from forming. The objective of my study is to synthesize nanocomposite bone scaffolds using bioglass and cellulose nanofibers, and the second objective would be to analyze the rate of degradation of bone scaffolds and the rate of hydroxyapatite formation. The significance of my study is that it would be able to propose optimum synthesis parameters for a nanocomposite bone scaffold which can produce enough hydroxyapatite for bone formation as well as has optimum degradation time. The scope of study is divided into two. The first is the synthesis of nanocomposite bone scaffolds using bioglass and cellulose nanofibers. In this part, two process parameters which are varied are the ratio of bioglass to cellulose nanofiber suspension, and secondly, the temperature of the drying oven. Meanwhile, the second scope of study would involve the study of degradation of the bone scaffold and the hydroxyapatite formation. The degradation of the bone scaffold is studied in simulated body fluid, where the mass of the bone scaffold samples are compared to come up with the degradation of the bone scaffold. Whereas for the hydroxyapatite formation of the bone scaffold, it is characterized through Fourier transform infrared spectroscopy analysis. The next part would comprise on the literature review that I have conducted for my study. For my literature review, I focused on the material that I have used in my bone scaffold, which is nanocomposite and bioglass. The properties of nanocomposite, which is high wettability, roughness, and surface area, which can promote bone regeneration since it allows increased protein absorption, nutrient exchange, and porosity, proves that it is a good material to be added to bioactive glass. Bioactive glass itself already has the ability to form hydroxyapatite surface layer when it is immersed in simulated body fluid. The apatite formation proves that scaffold interacts with tissues at atomic level, which can result in the formation of chemical bonds directly with the bones. The next part would comprise of the method that I have used in my experiment. In order to achieve the first objective, which is synthesis of bioglass and cellulose nanofiber composite bone scaffold, the first step is to prepare the bioglass and cellulose nanofiber suspension sol gel. It is made up of tetraethyl orthosilicate, sodium nitrate, calcium nitrate tetrahydrate, and triethyl phosphate. Cellulose nanofiber suspension is then added into the solution at varying percentages of 0 to 20%. The solution is then gelatinized using a template. Next, the sol gel template is oven dried in order to form bioglass powder. The oven temperature is set at varying temperatures of 700 degrees Celsius to 900 degrees Celsius. After that, the bioglass is then formed using a furnace at a temperature of 1000 degrees Celsius and above. Next, once the bioglass has been formed, it is dip coated with cellulose nanofiber suspension and freeze dried. After that, three types of analysis is carried out on the bone scaffolds, which is characterization analysis carried out using a scanning electron microscope and a Fourier transform infrared spectroscopy machine. After that, mechanical analysis is carried out using Instron machine, and finally porosity analysis is carried out using ethanol displacement method. For the second objective, which is degradation and hydroxyapatite formation study, the bone scaffolds are immersed in simulated body fluid. The simulated body fluid is made based on the protocol of preparing simulated body fluid, which is highlighted by the Kyoto University. The bone scaffolds are soaked in simulated body fluid for 21 days, and samples are tested with intervals of 12 hours, 18 hours, 1 day, 3 days, a week, 2 weeks, 18 days, and finally 21 days. The reagents used to synthesize the SBF is listed in the table. Next, the SPF immersed bone scaffolds are analyzed in 5 different ways. As for the characterization, mechanical and porosity analysis, it is carried out similar to the way it has been carried out in the first objective. Whereas 2 new analyses are carried out, which is bioactivity analysis and mass analysis. Bioactivity analysis is carried out to calculate the amount of hydroxyapatite that is formed in the solution, whereas the mass analysis is carried out to ensure the degradation of the bone scaffold using mass difference of the bone scaffold with the initial weight of the bone scaffold. The expected results of this study is to obtain the optimum synthesis parameters, which are the temperature of the oven and bioglass to cellulose nanofiber ratio in the nanocomposite bone scaffolds which produce functional bone scaffolds. And secondly, it is expected to be able to correlate the degradation of bone scaffold and the hydroxyapatite formation. Next, I have included the Gantt chart of my study. Okay, so for the activities that I have scheduled is from October to May. So the literature review is expected to be done by November. And now the first week of December comprises of the proposal presentation. The experimental work has already been done for the preparation of the bioglass sol gel. And the expected outcome of the objective 1 is expected to be achieved by the end of February, and then after that the objective 2 would be carried out. The experiment of the objective 2 would be carried out, and the results are expected to be obtained by the end of April. Finally, the thesis is expected to be completed by May. Thank you for your kind attention.